Hi there once again and welcome to another Expresso mechanic tutorial, and in this one we're going to be making one of these, which is of course a lava lamp. We'll use a number of different technologies within Cinema 4D to achieve this, including Expresso, Python, Dynamics and MetaBalls. Anyway, without further ado, let's see if we can make this happen. We'll begin by creating the components that make up the lamp. So I'll grab a sphere and I'm going to give this 24 segments. We'll keep it as a standard sphere, that'll be okay. And then I'll make it editable. My X value I'm going to set to 90, my Y 345 and my Z 90. Apply those values. And this will be the inside of the rocket. This will actually be an invisible object, a collision object that the Metaball components will be crashing into and held in stasis by within the rocket. So that's what this is going to be for. I need another 3 copies, so we'll create those by command dragging. And we can start renaming them. So this we said was going to be a collision object. I'm going to call this one top. This one glass, and this one bottom. So let's just start moving these around and space them out. We change to a side view, so function 3 to go into a side view. And I'll just move these out of the way. So I'll move my top, my glass, and finally the bottom, move those over there. And then I can start thinking about what I'm going to do with these. I'll switch to polygon mode. And as this is at the bottom and we've got it already selected, we may as well start working with this one. So I'm going to select all of these polygons and remove them, just leaving this section here. Select the glass, and in this one I'm going to be removing the top and also the bottom section. And in the top I'm going to remove all of these. So that gives us 3 separate components that will make up the rocket. If we go into our 3D view and hit O to focus on the top, what I need to do is just select all of the polygons by hitting Command A, and then I'm going to hit D for extrude, and we'll go, I think we'll try, let's try 5, or shall we, I'll tell you what, let's go 3, go 3. If we go 3 and we'll say create caps, that's going to be very important, and we'll apply that, and that's given us an object with a good amount of thickness. It's not too thick, but it's about right. 3 should be fine for that. Now let's go for the glass, and we'll do the same thing with that. Just select a polygon, select all, D for extrude, and this time I'm going to go 2.5. In fact, what I may go lower than that, but I'll say 2.5 for now. We'll go 2.5. That should work okay, actually. If it's a little bit too thick, you can always work with it and just make it a little bit smaller in there, but it should be okay at 2.5. And then finally the bottom, again select a polygon, select all polygons, D for extrude, and go back to 3 and hit apply. And that's the components essentially sorted out thus far. Now the bottom, obviously we need some legs to come out of there that the actual rocket can stand upon. And what I did here, I'll just go back to my selection tool and make sure it's set up okay, so we've got visibles only, which is important. I'm going to just hit O again to zoom in closer to the bottom piece, and I just need to select a couple of polygons there. And now I've got 24 rotation segments, and you'll see that this works quite nicely because obviously 3/8 are 24, so I can say 1, 2, 3, 4, 5, 6, 7, 8, and then select this polygon. Oops, I just need to hold down shift before I do that. So we go, let's just work this out again. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, select this polygon. I'm just going to rotate round a little bit and then select this one. And then I can do the same again. So 1, 2, 3, 4, 5, 6, 7, 8. So select this one and select this one. Okay, and that works fine. Before I go any further, I need to come up to Mesh, and in Remove, I need to say Melt, because I want these to be n-gons so that we can use them more easily. And then the next stage from here is to hit MX for Matrix Extrude. And then we can work in here and create our legs. Let's just change the view slightly so that we can get a better picture of what we're doing here. Let's just zoom out. Okay. What I'll do, I'll just hit apply and see what happens. So we can see that our legs are a little bit too long. Let's change those down to about 20. We'll try in there. Well, that's not too bad, is it? Already looking pretty darn good. I would say that we'll probably get away with that. I'd say that was about right. Let's just go into a top view and have a look at this object. Now, we're not quite right here, so we've got a bit of a twist in there that we don't want. So let's see if we can correct that. We'll take it back. Yeah, if we just take 3 off there, just go -3, that's absolutely fine. I think that'll do nicely. I think that'll work. Yeah, that gives us, I think, what we want, doesn't it? Looks pretty good. Okay, so that was simple enough to achieve. The next thing really is to group these now into a null. If we just bring a null in, and on this occasion I won't use Alt-G to do this, and there is actually a very good reason why I'm doing that, because I actually want the null in the center of the collision object, and then we can simply grab a hold of all of these, group them into a null, into our null I should say. Don't want to do that. Let's just select model mode, and then you can see that the Z, we just need to 0 these out and get them effectively where they need to be. We'll need to do them individually, so just get the bottom and 0 that out, the glass, 0 that out, and the top, and 0 that out. And now all our components are in the center of the world, which is where we want to start from. Obviously you can move your rocket around, but the center of the world is where we need to be for a start. Moving on from here, I'm also going to drop in my collision object too, and I'm going to call these rocket, or rather lamp. I'll call them lamp components. So lamp components, they're there. And then the next thing is to select this and drop it into a subdivision surface. So I'll hold down my Alt key and select one of those. And now I've got that dropped in there. It's not 100% correct, as you can see. And the way we're going to deal with that is quite simple. I'm going to add bevel deformers to each of the 3 components. So the top, the glass and the bottom. So let's come into our deformers, hold down Shift and select a bevel deformer. I'll Command drag to copy that one and place it in the glass and the bottom. And already you can see that that's working really well. The offset I'm going to just change. I'll select the others. I'll just Command select the others. The offset, I may leave the offset at 1. I think 1 is fine. I think we'll leave it at 1, but we'll change the subdivision to 2. Don't use 3, because if you do, it might not work. But well, actually 3 does work. It's probably going to be okay then. I'll leave it at 3. It's interesting, the last time I did this when I was making it originally, when I put 3 in there, the model actually disappeared, so it didn't work. But this time it seems to be working fine. But you can see that that's looking really nice. It's given us a really good result, and those components all work well together. So the rocket's looking great. And that completes that stage of it actually. So the model is ready, it's ready to go. And the next thing from here will be to start working with the Metaballs that are going to provide us with the lava inside the lamp. The first thing I'm going to do before I get to the spheres is take this out of the hierarchy there. And I'm going to rename the subdivision surface rocket lava lamp. And then I'll make this disappear from the viewport for now. And we'll close it up. In our collision object, I'm going to give this a display tag. So we'll come down to render display. Switch this on and change from garage shading to lines so that we can see through the object. And this of course is going to be a collision object, so it will need a dynamics tag, and we will give that a simulation tag, and it will be a collider body. It's already set up perfectly well for us, so we don't really need to change anything. The collision is static mesh and that's all fine. We will use margin and we'll play around with this a little bit later. Moving on from here, we can think about bringing in some spheres to create our Metaball object. So let's get hold of a sphere. Well, what I'll do actually, I'll just make this 10 for now. I'm gonna work with the radii of the spheres a little bit later as I've brought them all in. The segments I'm going to take down to 6. It will be an icosahedron in the type, and I'm going to take away render perfect because we don't want that on. Moving on from here, I can start to copy. So if I copy our first sphere, select both, copy, select all 4, copy again, and then select the bottom 2 and copy these. I've now got 10 spheres, which is what I need. We can start to space them out too. So if we bring the first one down to there, and we can change its radius. Actually, the radius for the second one, that is fine as 10. I'll just select the first one and make the radius for this 7.5. Select my second or my third sphere, sphere 2, which is my third sphere, and make the radius for that 5. Next one down, move it out of the way, and the radius for this can be 12. I mean, you can experiment with the radii, you can do whatever you like with them, but this is just what I found worked well for me, so I'm just going to set it up the same way. 13 for the next one. And 7.5. Drag this one down to the bottom. And this will be the biggest one for me, which will be 15. So that's the biggest one I'm going to be using there. And the next one will be the smallest, and that will be 4. Drop the next one down. That is correct at 10. And finally, sphere number 9 will be 7.5. And that's my spheres complete, so I can drag those collectively into my rocket collision object. Leave those in there, and then if we select our top view and hit H, we can see that they're in the correct place. Okay, so that's good. So we've got that all sorted out. These can then be dropped into a Metaball. Now, with the Metaball object, we can just drop it in there first, and then select all of our spheres and drop them into our Metaball. At the moment, it's just very blobby. The editor subdivision I'm going to take down to 5 to match the render subdivision, and that helps enormously. The hull value is something that we will have a little bit of a look at later, but we'll leave it where it is for now, and we can also use exponential fall off should we be having any problems. But anyway, we'll move on from here and start giving our spheres dynamic tags. So we'll select our first one, and we'll come down to simulation tags, and we'll give this a collider body, or rather a rigid body, I should say. In our dynamics settings, in our dynamics tab, we're actually okay. We don't need to change anything. In our collision, apply to children and all, they can be left there. That's absolutely fine. Don't need to change those really. We'll leave everything else. The shape we'll change to ellipsoid, and we will switch on our collision margin, and we'll leave that at 0. In the mass tab, I'll change to custom mass and set this to 1. Now the forces tab, we will be placing gravity objects in here. We'll be placing those in there and we'll be including them, but we won't be doing that yet, so we'll leave that blank for the minute. Okay, but that's for something we're going to be doing later. We can't use soft bodies for this, unfortunately. They've got to be rigid bodies. I did try to use soft bodies, but it's just a bridge too far. You can't use it. It just won't do it. So we're going to have to stick with rigid bodies for these. Okay, that's great. So we've got it that far, and now we can think about copying these to our other spheres. So we'll copy those down. And now they've all got their rigid body tags. So let's just run the timeline and see what happens. Well, nothing is happening at the moment. So if I just hit Command D and go into our general tag. Now at the moment I've got my gravity set to 0. It needs to be set to 1000. So we'll switch that to 1000. And now we'll try running the timeline again and see what happens. And this time everything falls down and we get a blob at the bottom of our collider object. Now you can see that it's actually proud of the collider object. It's not actually being kept within. To start sorting this out, if we just go into our collision object here and go into the collision tab, with our margin I'm going to set this to 3.5 and see if that actually does help. Well, certainly it does, but it's still not solved the problem completely. You can see that it's still slightly proud. And this is where we can start looking at the value of the hull in our Metaball object. Now we can switch on the exponential fall off, and that does help. It's a little bit too much though, so perhaps we can do something with the hull value. Let's just take this down and see what happens. Well, it's going the wrong way, isn't it? So that's no good. So let's go up. If we go up to, let's go up to about 120 and see what we get there. Well, that doesn't look too bad, does it? If we just come out of there, yeah, you can see that is actually about what it needs to be. So if we leave the hull value of the Metaball at 120%, I think we'll be okay. As I say, we've still got the exponential fall off. We can use that, but I prefer to work with the hull value first. This is useful in certain instances, but I think we'll keep the hull value as the value that will change. So that's great. So we've got it that far and everything is working. So we can drop this down and leave that there as a start position. We'll just edge through till we get to 90 frames. And we can then select all of these and we can set in the Dynamics tab an initial state. We'll just click on initial state. Go back to the beginning and they're ready to use. I'll then do Command D again, hit Command D, and in my general tab I will take away the gravity. I do want the gravity to be 0 from this point onwards because it's no longer our friend. We're going to be giving each of these spheres its own gravity. So we don't want the general gravity to be used because it will cause a conflict. Okay, so we'll leave it like that. In the Expert tab, everything I'm going to leave in there. I've already taken the maximum iterations. They were originally 10. I've taken them down to 5. We'll leave it at 5. And that's fine. That's everything we need to do in there. The next step then is to bring in the aforementioned gravities for each of our spheres. So in our Simulate menu, we can come down to Forces, Gravity. And that gives us our first one of those. What we'll do, I'll just group that. I'll hold down my Alt key and hit G, and we'll group this into a null. So we've got that sorted out, and we can call our null gravities. And we'll start copying again. So I'll hold down Command, copy, select them both, copy again, all 4, copy again, and the bottom 2, and copy those. So that gives me the gravities that I need for each of our spheres. The accelerations, what I'm going to do here, To be honest, I don't really need to do anything because I'm going to be controlling this using a Python expression and, well, a combination of Expresso and Python actually. But I could set this just to 0 initially. What we can then do is start moving on and start placing these within our spheres forces tab or force tabs. We'll set this to include. In fact, what I'll do, if I select all of these and I just say include, and then I can go through one at a time and just drop them in. It's the only way to do it. So let's just go in here, drop that one in, drop this one in, and probably by the power of editing I'll put a cross dissolve here so that you don't get bored watching me put all of these into the forces lists. And finally we'll put number 9 into there. So now we've got all of our gravities in our forces lists within our dynamics tags. And that's great. So that's the next part of this sorted out. Moving on from here, we can think about starting with Expresso and Python. So let's get a null, rename it Expresso. We'll give it an Expresso tag, get the window open and start work. The first node that we're going to need will be an iteration node, so we'll bring one of those in, place it over here on the left, and we'll leave it at integer because we're working with index values. It will start at 0 and it will end at 9 because we have 10 spheres and of course 10 gravities, and we need to work with both of them. In order to do that, we need to bring in a couple of linked lists. So we'll bring one in and then command drag to copy out another one. And we'll just rename them. I mean, we'll call this one gravities and this one spheres. And that's great. So we've got those sorted out. And what we can do here, we just select and go into our node. In our linked list, we can select our arrow and start bringing in the spheres. So we'll bring all of those in. So we've got all of our spheres in, that's great. Click off of the arrow, select our gravities node, and then repeat the process for our gravities. And we've got all of those done, so we can click off our arrow. Our iteration we can plumb straight into the indexes of both of our nodes, our linked list nodes, and they're now ready to go. Moving on from here, I'll pull a sphere in. At the input stage, I'll give it an object port, and at the output stage, I'll come into coordinates, position, and give it a position Y port and make it bigger so that we can see what we're doing with it. I'll also bring in one of our gravities, and again at the input stage here it's going to have two inputs actually, so it's going to be an object port which I'm going to use to connect it to the linked list, and I'm also going to bring in an object properties acceleration port, and that's now ready to go. The last node that we need will be the Python node, so we'll bring one of those in, and as per usual I'll remove the ports and start from scratch. The first port that I'm going to add will be an integer, and I will rename this port simply I for index, and that will be coming from the iterations output port, but we won't connect that just yet. The next port that I'm going to add will be a float value, and I'm going to call this pos y. So pos underscore y. And that will be the position y from this sphere node. The final port that I'm going to add will be on the output stage. Again, it will be a floating value, a float value, and I will rename this one acceleration. And not surprisingly, this will be connected to the acceleration port of the gravity. The next step then is to change to a coding layout, and we'll start thinking about doing some work. Let's just select our Python node, open in the Python editor, change to a Python editor layout here in the console. And now we're ready to start doing some work and getting the code done. I'll also open the Expresso editor, I think, so that we can have a good look at this. If we just say view frame all, in fact what I'll do, I'll make it even smaller and then say view frame all. Okay, so that gives us an idea of what's going on and how these two things are going to relate to each other. I'll remove this line, and then up the top here, we'll start from the top and work downwards. I'll say import random, because we're going to be working with random values. And above the main function, I will put random.seed. And then it doesn't matter, just put a random number in there. It can be any number you like in there, but it's just something that I'm going to do so that we get the same animation every time we run the timeline. I'll also add global status, and you'll see why in a minute. If we just come down now, and we need a variable for our frame, and we've done this many times if you've seen any of my Python tutorials with the effectors. So frame is equal to doc dot get time get frame doc get fps open close close. So now we can get our frames from our timeline, as we so often do. Great. So moving on from here, we can say if frame is equal to 0, we'll set up our status. So status is equal to, and it will be 10 zeros in here. So 0, 0, and that's the 6th, 8, 9, 10. Just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got an 11th one. Just take that one away. So that's status set up. And what these will be are the statuses of our gravity's acceleration. So they're going to be passed from here to here. Moving on, we can now say if pos y is less than or equal to minus 100, coin is equal to random dot, or rather random as a word, I should say, random dot randint brackets 0, 1. I'm going to code all of this and then explain exactly what I'm doing here. Speed is equal to random dot uniform 0, 0, 3, 0. Status dot pop brackets I if coin is equal to 0, status dot insert brackets I comma minus 10 plus speed, else status dot insert I comma -10 minus speed. So what exactly are we doing here? Well, we're checking the position y of the current sphere, and of course these are being looped perpetually via the iteration node here, so we're getting a constant loop. So if the position y of the sphere that we're currently looking at is less than 100 units, and it's important to note that it's minus 100 units from the center of our rocket, so minus 100 from here. We're then going to toss a coin and get a random value between 0 and 1. Our speed is also going to be a random value, and I've used random uniform here because it generates a range of numbers, and they're floating point numbers, hence why I've used 0.0 as opposed to just 0 and 3. So it generates a range of floating point values between 0 and 3. The next thing we're going to do after this is, from our status list here, we're going to remove, pop actually removes the value at the current index position. So if we were working, suppose that sphere 2 over here, that's the current sphere that we're looking at, we would actually remove the third value, because of course we start from 0, so 0, 1, 2. This 0 would be removed from the list via this pop, because it would be the index value I. So at index value I, remove this value. That's what we're saying there. And then we'll check our coin. So if our coin was 0, what we would say is that within status, we will insert at position I. So at position 2, we'll insert a value of -10 plus whatever the random value speed has generated. Okay, that's what we're going to do there. Else, we're going to just insert at position I -10 minus speed. So this is allowing us to put a variable speed value within our status list at the current index value. That's what we're doing with this, and I hope that all makes sense. Moving on from here, I'm going to copy this piece of code and paste it in, and then I'm simply going to say is greater than or equal to 100, and the rest can be left exactly the same, because all we're doing now is saying that when we're greater than, or 100 units greater than, the center point of our rocket, then we can start thinking about doing something different. Now, the only thing I need to change actually is this. I need to say 10 rather than -10, because 10 or positive values within a gravity object make things fall, negative values make them rise. So that's why we're doing that. And that really is all we need to do with that part of the code. To finish this off, we just need to give these values that are being generated to acceleration at the output of the Python node. So we can simply then say acceleration is equal to status square brackets I, and that completes the code. It's very, very simple. There's nothing, particularly complicated about any of this. So moving on from here, let's connect the various nodes from our Expresso editor here. We'll just get these connected up, and then we can think about having a go at this and see if it actually works. Right, so it's the moment of truth. Let's just close down the Expresso editor and we'll click out of here. Before we start, I'll just come up to our layout menu and switch back to a standard layout so that we get things a little bit larger. And our Metaball, let's just give it a colour, just a basic colour. Let's just give it, I don't know, just give it a green colour, shall we? That'll be quite interesting. Just give it a bit of a green colour there. There you go. Okay, so that's a bit psychedelic and we're ready to run. I've given our timeline 3000 frames, so we've got a few frames to play with. Let's just see what happens when we run the timeline. Yeah, and you can see that it's working. It is actually doing what it's supposed to do. And there's a little bit of variation in the speed of each of the spheres. There is a subtle difference there, and that will of course change every time they get processed by our Python code. Yeah, but it's all working quite nicely. All right, it's not 100% perfect, but you can see that it does actually do what we set out to. And we've got something that resembles a lava lamp. I mean, it would be great if it did work with soft bodies. I think that would make a bit of a difference. And also maybe if you could do a particle-based setup, that might be quite good as well. But I mean, for what it is, I think this works pretty well, actually. But anyway, let's bring the rocket back in and we'll see what it all looks like when it's all there. So if we just bring our rocket back in, and what we'll do, we'll just open this up, we'll drop the collision object back into its original position, and with the glass what we'll do there is just drag this object or this tag onto there, and now our glass is in wireframe mode. And in fact we need to copy that really, so let's just copy that back onto there. Okay, so now we've got our rocket in place and our glass is transparent and we can see what's going on within it. If we just run that, you can see that the effect is quite nice. It actually works very, very well. And it does look like a proper lava lamp. But anyway, that's how you create one of those. That's how you go about doing it, using Python, Expresso, Dynamics and a Metaball. To finish this off, I'm just going to create a quick texture for our glass in the luminance, or rather in the transparency. I just need that is absolutely fine. I won't change that at all. It's just going to be a basic texture. I'll just put that on there. Throw this onto our glass. And now we can remove this tag actually. And we can see that the glass is now transparent. So that's fine. And then I'll put a couple of lights in the scene. The first one I'm going to leave inside the rocket object. And the second I'm just going to move, just place it in the scene so that it just gives us a bit of general light. This is literally just to give you an example of what I did. This light, which is inside the rocket, if we go into the general tab, go into colors, we'll just give it a cyan or aquamarine tint. Visible light needs to be switched to visible. Everything else can be left the same. And then in the visibility tag, 500 is much too big. Let's take that down to something like 40. Could be a little bit higher than 40 actually. In fact, what we'll do, I think I'll put it at 50 for the outer and 45 for the inner. That should actually work quite nicely with this. And then 340% for the relative scale in the Y, so that we're just outside of the object. And then if we just take a quick render and see what we're getting. Okay, so a couple of things we need to do, or one thing we need to do is certainly switch off the collision object. We don't want that visible. Okay, so let's see what we're getting now. And there you have it. So that's how I created that effect. And obviously you've got to light the thing properly, and you might want to do some other texturing as well. I'm not going to go into that now, but that's just the way to set up the light within the thing. And also in the general tab, it's a little bit too bright. The intensity needs to be about 60%. So let's just set that to 60 and give that another render just to see what it looks like. And that's better, isn't it? You can see that it's got a sort of general sort of glow and it's not too intense. So that's great. It's looking good. And that's it. Essentially, that's the way you create the model. But I'll leave the other texturing and stuff up to you. You'll make a much better job of that than me. Texturing's not my forte. I'm a sort of animator and into sort of doing Expresso and code. That's my forte. But there's much better texturers out there, and you're probably one of them. But anyway, that's about that one done. And that about completes this tutorial. As always, I hope you found it worthwhile and that you've learned something new that you can use within your own projects. And if you have enjoyed the video, then please give it a thumbs up. And if you haven't already, please subscribe to the channel and ring the bell. And of course, wherever you happen to be on social media, please share this video, because all that good stuff helps to keep the channel going in the right direction. And feel free, of course, to leave a comment. But anyway, that wraps this one up. So I'll see you very soon on the next tutorial.